And so this is the test that we had. These are some practical C questions, and we're going to look at how we were supposed to maybe handle this, and also give a few pointers here and there. And I think what we can start by doing is we can start by creating our C project, where we will write our C code and also write different comments for the file that we will cover. So we can say it's called cat2 revision, and we can just save it there and open our main file, and we can just clear everything so that we can start from scratch while doing these programs. And the first question is asking that a student created the following C program during a practical lesson. Use it to answer the questions that follow. And this is our program that the student has written, and when you have such a program, it's good to just go through it and see whether there are any maybe syntax errors, whether you'll meet with anything that is not at the required place. So you can see that the program is starting with hashtag include stdio.h, and yeah, that is actually good because there is no typos. They haven't written something like studio.h, so it's normally stdio.h. And then they have the int main function, and then they have the opening and closing curly brace for the main function. And then we have our number 1 and number 2, which are integers, and then we have our semicolon. And number 1, we are told that it's equals to 25, so that is one of the things that we have to consider, that we have been told number 1 is equals to 25, and then number 2 is equals to number 1 minus all this, or just whatever the evaluation of this is equated to number 2, and what we are required to print is actually number 2. And you can see it's %d, and this %d is substituted with the variable num2, and we have return 0 at the end. So that is our program, and we can see that there are no syntax errors, there are no any errors, because you can also, in an exam, you can also be given a program like this, and then you are told to identify the error and fix it. So if maybe here they had written something like %f, you could have noticed that the error is in the format specifier %f, because %f is not used with an integer, so it's normally used with floats. So that is one of the errors you would have noticed, and maybe the program maybe did not have a return 0, something like that. Just know that you can be asked such questions too. So after we've seen our program, I think we can first try to evaluate it manually. How we can evaluate it manually, like, because that is exactly how you'll be doing in an exam, because you won't have your C programming IDEs or the app that you use to program in C. And so let us see, and what I'll do by this is I'll have a comment. So cat2 revision answers, and the first one is question 1, and it has now this, and let's see the program itself. So I think we can write the program itself in our IDEs. Include hashtag, so we start with hash include, then stdio.h, and then we go to our int main, and then we can print. Okay, we don't have to print anything, we can say return 0. So this is our main method, and the first thing is int num1, and then we have int Is it int num2? No, it's num2. And then we close our statement, so you can see that the semicolon is there, and then we say num1 is equals to 25. Num1 is equals to 25. So you can actually write it on the same line or divide, but let me just write it as it has been written in our test. And then here it's something like num2 is equals to num1 minus 3 times 4, and then plus 6 times 2 plus 3, then plus 1 plus 5, 1 plus 5. And I think that is our, this is our sum, or our expression. And then it's printing num2 is equals to %d. So we are printing num2 is equals to %d. Then we go to the next line and saying num2. So that is our program. So even before we run it, let us evaluate it manually. And what we have here is that we are being told that num1 is equals to 25. So think of it as the value for number 1 is 25. So anywhere you see number 1, you have to substitute with 25. And then we've been told that num2 is equals to num1 minus 3. So it's just this expression. So I can just copy it and paste it here. So this is our num2. Num2, you've been told, is equals to this whole expression. And what you can start by doing is now substituting everything. In case of num1, you substitute num1 with 25. So you say num2 is equals to 25 minus 3 times 4, and then plus 6 times 2 plus 3, and then plus 1 plus 5. And here is where now we have to know how the order of operation in programming. And in programming, and how, what we normally do first is we first take care of the parentheses. You evaluate the parentheses or the brackets. It's the same thing as how you do board mass, but it has a difference. Okay, it has a difference. And after parentheses, you do the division and then multiplication. So you do evaluate, division, and multiplication. That is what you can do. And then the third one is now evaluate, addition, and subtraction. But here there is a catch. Okay, this is not the typical way you do board mass. So you'll see how we will do it. How it's normally done when it comes to addition and subtraction. So let us just first evaluate this, and we'll say that num2 is equals to 25 minus you evaluate these parentheses. So inside these parentheses, it's saying that is 3 times 5, which is 15. Okay, then plus 6 times you evaluate the parenthesis, which is 2 plus 3, which is 5. So it's 6 times 5. And then plus you evaluate the parenthesis, which is 1 plus 5, which is 6. And then after that, you can see here we have a higher order of multiplication. So we have a higher order symbol, which is the multiplication. And we're going to evaluate the multiplication first. So you say num2 is equals to 25 minus 15 plus, what is 6 times 5 is 30 plus 6. So that is how we can do that. Now here is where you have a catch, and when you have just addition and subtraction, the operation is normally uh, done from left to right. So you just start from the left going this way. You can actually just plug in your values in a calculator from here going this way. So you just say 25 minus 15 plus 30 plus 6. Okay, don't do something like 30 plus 6 or 15 plus 30 plus 6, because that is how something like board mass would tell you that addition comes first. No, when you have just addition and subtraction, the operation is normally done from left to right here. So you start with 25 minus 15, and then whatever you get there plus 30, then plus 6. So it's something like 2 is equals to, what is 25 minus 15? That is 10. Then plus 30 plus 6. And then 2 is equals to, what is 10 plus 30? This is 40. Then plus 6. And then 2 is equals to 40 plus 6, which is 46. And that is the actual answer. So the problem could have come here. So after you've dealt with the multiplication brackets and where there's divisions, those ones just follow. Where it can be tricky is when we have now the addition and subtraction. So you just it's normally done from left to right. And if we now run our program, let us see whether we'll get our answer to be 46. So let's see. Build is succeeded. So it should output num2 is equals to whatever the value it will get. Let's see whether it will get our same value, which is 46. So okay, 49. I think I have done something wrong. So I think I have 3 times 4 is 12. 12. So here it was supposed to be 12, not I see where I wrote here 3 times 5. So it's 25 minus 3 times. It should be 3 times 4. Okay, so it should be 3 times 4. And what is 3 times 4? 3 times 4 is 12. So 12 and 12, and that was just the problem. Everything else remains. We had done it. It's just that here I had written 3 times 5, not 4. So it's 25 minus 12. So it's 25 minus 12 plus 30 plus 6. So what is 25 minus 12? 25 minus 12 is 1 and 3. So it's 13. What is 13 plus 30? That is 43. What is 43 plus 6? 49. So that is the same thing that you're seeing here, that the answer is 49. So you can see when we have just addition and subtraction, just be doing follow the operation sequentially as is, as compared to the case here where we had to do 6 times 5 first, and here we had to do 1 plus 5 as one of the first operations because it was inside the brackets. So I hope you've understood that, and that is how we can have our program to be evaluated. So I think I can copy this code and paste it up here, because I'll be sharing this document, and yeah, so let us look at the second question which says do while loop. So this is about a do while loop. And also, if you have questions, you can have them here in the chat. You can write your questions here in the chat if you have them. And let us look at the do while. What is the do while? Question 2. Okay, this is about the do while loop. And what it's asking is that write a program to display all odd numbers between 91 down to 37. Program to display all odd numbers between 90 what is it, 97 91 down to 37, 91 to 37, inclusive. So there's a keyword here, inclusive. So anytime you see this keyword inclusive, that means we are going to be using a symbol such as this, greater than or equals to, or less than or equals to, something like this. That's what denotes inclusivity of that number. And how do we write a do while loop? So to write a do while loop, you normally write do and then while. So this is the normal syntax of a do while loop. You write do, so whatever you want to be executed, you write here in the do part. So if you want to print something like hello world, so printf hello world, and you want to print it maybe like 10 times. Okay, you could maybe have a variable here called int counter, and this counter will start from 0. So int counter is equals to 0, and then counter plus plus. So you have to increment the counter here. So every time the loop is executed, you increment the counter itself. And after you do that, the condition is that while the counter is less than 10. So this will print 10 times. Because we are starting from 0, we can say less than 10, because this will go up to 9. But since we are starting from 0, that means those are 10 different things. Those are 10 different prints. And when I run this program, it should print hello world 10 times. This is how we can use a simple do while loop. So let's see. And you can see that it has printed hello world. So let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the reason is because we are starting from 0. And also, if you wanted to display the actual number itself, you can replace here with %d, and then you display counter, and that will display the number itself, like number 1, 2, 3, 4, 5. So it will start from 0, 0, 1, 2, 3, 4, 5, 6 up to 9. And it's because here we have used less than 10, but we said if it's something inclusive, we add an equal sign. And this means that our 10 is inclusive. So when I run the program, you can see that it will print 10. Okay, it will print 10. So that is what we mean by that. And now what we are required to do in this test is to display all odd numbers between 91 to 37. And the first question is to ask yourself, how can you display an even or an odd number? So what determines whether a number is odd or even? And the first thing is that if a number divided by 2 has a remainder of 0, that is an even number. And then for an odd number, if actually you can say any number divided by 2 has a remainder of 1, that is an odd number. So that is how you can determine whether any number is an odd or even number, is by dividing it by 2 and doing the remainder. So to get the remainder of any division, we normally use the modulus operator, and the modulus operator is normally represented by the how do we call it, the percent, is it the percent to represent our modulus operator? Here it's the percent. So what it does is that it takes whatever number is on the left side. So if we were to say something like example, so let's say examples, we have something like 7 or 6 modulus 2. This is equals to, if you divide 6 by 2, this is 3 remainder 0. So the answer is 0 here. So 6 modulus 2 is equals to 0. So we have divided 6 by 2 and then taken the remainder, of which the remainder was 0. So the modulus operator just only knows about the remainder. It doesn't know about the result. It doesn't care about the result. It cares about the remainder. The same case if you were to do 7. So we do something like 7. So let me tab. So we do something like 7 modulus 2 is equals to, or let me say 9. 9 modulus 2 is 4, because 4 times 2 is 8. So it's 4 remainder 1. So 9 modulus 2 is equals to 1. And this is how we can now evaluate whether any number is odd or even. So if the number divided by 2 has a remainder of either 0 or 1, so if it has a remainder of 0, it's an even number, and we can actually do that. So we'll get to the while loop in a few. So if I was to do something like this and say int result is equals to 6 modulus 2. So let us see what the result will be. Printf and then say result is equals to %d, and then we can say it's what result. So let's see whether this should be equal to 0. So 6 modulus 2 should be equals to 0. So let's see whether the result will be equals to 0. I think I can replace. So you can see here, result is equals to 0. Because it has done what we have done here. Because 6 modulus 2 is 3 remainder 0. And we are only interested in the remainder, which is 0. And the same case if I was to do here 9 modulus 2. 9 modulus 2 and print out the result, you can see the result is 1. And it applies for all numbers. If I was to write here any number that is even, you will see that the result will be equals to 0. And if that number becomes odd, I add 5 at the end, that number becomes 1. And that is our basis. That is our basis of determining whether a number is even or odd. So I hope you've understood that. And now what you're required to do is write a program to display all odd numbers between 91 down to 37 inclusive using a do-while loop. And so what you can do is, first thing, we can display all numbers between 91 and 37. So that is our first task. We can try to display all odd or all numbers, not just odd. Let us first try to display numbers. So we'll have, where do we start? So we have int number, it will be equals to 91 because we are starting from 91. And what do we want to do? We want to do we want a do while loop. So we want to do, that is the syntax of a do while loop. So it's normally like that. Unlike a while loop, which is just while, this is just a while loop. And a do while, it has the do and the while. And this is just the while loop. So the while, you write your condition in here. And then for the do while, you write your condition after the loop has done. And the difference is that the while loop, it tests the condition first, but a do while, it executes the statements first before testing the condition. So the difference between a do while and a while loop is that one tests the condition before, and the other one tests the condition after. So we can say difference major, or we can call it the major difference between a do while and a while loop is that a while loop tests the condition before, and a do while, I think I can write it in a new line, and a do while loop tests the condition after. Okay, so this normally happens after, and then a while loop, it tests the condition before. And as you can see, that's why the do is happening first. That is the major difference between a do and a while loop. And what we've said is that we are starting with our number, which is 91. So what we can do is we can print out the number, print f %d, and then we can go to the next line, and this will print out our number. And after printing out our number, because we are going down from 91 to 37, we have to decrement, or we have to decrease the number by 1. So you say it's number minus minus. You can either say number minus minus, or you can say number is equals to number minus 1. Okay? You can say it's either number minus minus, or it's number is equals to number minus 1. Or you can say number, there are different syntaxes to do this. So you can say number minus equals 1. These are different. All these are the same. Okay? All these are the same. But the one you'll find mostly being used is this first one. If you're decreasing by 1. If you are decreasing by 2, you can write here number is equals to number minus equals to. If you are decreasing by 2, number minus equals to. So we'll use the first one, number minus minus, and we are doing that while the number is greater than or equals to 37. So this will ensure that we won't go to any number that is below 37. That is below 37, and you can see that 37 is included because we are using the equal sign. And now if we do that, it should print all the numbers between 91 and 37 and 37. So now the question is asking us to print out what do we have here, down to, but in this case we are displaying odd numbers. We are displaying odd numbers from 91 down to 37. So that is what we have to do. And actually there's a trick you can use here. Since we are starting from number 91, there's something that you can do, and this is just using logic. And we know that if I was to write 91 90, then 89, then 88, 87, 86, 85, 84, 83, 82, then 81, then 80. If I was to write this, let me just go to 81. We know that the odd number is always, if we start from 91, the next odd number will be 91 minus 2. The previous odd number is 91 minus 2. What is 91 minus 2? 89. What is 89 minus 2? 87. What is 87 minus 2? 85. What is 85 minus 2? 83. 83 minus 2? 81. And also, if I was to start at 90 and then I minus 2 every time, that will give me all the even numbers. So 90 minus 2 is 88. 88 minus 2 is 86. 86 minus 2. So we are just jumping the number that is before. So we just jump the number that is before. 86 minus 2 is 84. 84 minus 2 is 82. 82 minus 2 is 81. So actually, to have a very simple cheat code, you can say number is equals to number minus 2, or you can just say number minus equals 2. You can say number minus equals 2. This is the same way as writing number is equals to number minus 2. And let's see whether it will actually print out the odd numbers. And as you can see, it's actually printing the odd numbers in their respective order. But this one is very, very tricky. If you're given some very weird conditions, it wouldn't serve your purpose. Okay? It wouldn't serve your purpose well. Because let's say if you are starting from something like 90. Okay, this one is very dependent on the number that you start with. If you are starting with 90, see that it will just print out the even numbers. You can see that it's printing out even numbers. So if you start with an even number and then you do this trick of minus 2ing, it will just do whatever the starting number is. So now, to be foolproof of that, what we need to do is to use now the standard way of doing it, to use the modulus operator to actually do the math itself. And now to do that is we need to use an if statement. And only print when our number is even. So here, use a modulus operator to determine even or odd. And what you can do by that is just say if the number modulus 2, okay, so if the number modulus 2 is equals to 1, if the number modulus 2 is equals to 1, it's the same thing that we have done here. If this number modulus 2 equals 1, okay, here, so if the number modulus 2 equals 1, this means that odd number. This means that this is an odd number and the upper one is an even number. That is how you can do that. So if the number modulus 2 is equals to 1, this is an odd number. This means that it's odd, or it's an odd number. It will fit. And if it's an odd number, what do you want to do? We want to printf, and then we say %d. Then we can go to the next line. And what is our %d? Our %d is the number itself. And now outside the loop, outside the condition, is where we do our normal decrement. So you say number minus minus. So this will ensure that our number is decreased every time till it gets to 37. And this is now the foolproof way you can display your odd numbers. So you can see that it's actually displaying the required odd numbers from 91 to 37. So this is how we can display our odd numbers. So I hope you've gotten that. And yeah, the major thing was here. So this is where you really need to understand what is happening. And we're saying if number modulus 2 is equals to 1, and that means that it's an odd number. If we said here if number modulus 2 is equals 0, so this is a relational operator, so it will relate between these two and see if the value that has been obtained here is either 1 or 0, and in this case we are saying 0, so that means we are testing for even numbers, and it should display even numbers. Now you can see it's displaying now even numbers. So this is the standard way. If I write there 1, we should display now the odd numbers, odd numbers. So that is it. And yeah, that is it how we can do. And if you were to now change these numbers to something like 101, and this one to be something like 11, it will now display all odd numbers between 101 and 11 inclusive. So let us see. You can see that is starting from 101, 99, 97, 95, blah 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 to 13, 11. So this is our starting number, this is our ending number, and our starting number we've been told is 91 to 37. 91 to 37, and that is how you are. That is how you can do that. And I think I can cut that code and paste it to question 2 to answer it. So I can paste the code here, here. So that is what was required of that. Okay, so int number, and then you say do while blah blah blah, and then we go to now the other question, which is question 3, and it says that Taifa Sacco registers an applicant upon payment of registration fee, and a registered member may apply for a loan after making monthly contributions for at least 6 consecutive months. Write a pseudocode to represent this logic. So when you see the pseudocode, we talked about the pseudocode, and we say that pseudocode is not the actual C code that we are supposed to write. And now for the pseudocode, okay, there are so many ways of writing a pseudocode, so it will not be guaranteed that whatever is here is the only way that you can do it. No, not at all. You can actually do it in your own way, as long as your logic still remains. As long as your logic still remains in such a way that you are able to express that an applicant is able to register upon payment of a registration fee, blah blah blah, and then you write all these conditions that are required here. And here is to test and see whether you know how the computer makes decisions. And you can see that the first caveat is that it registers an applicant upon payment of a registration fee. So if you haven't paid a registration fee, you cannot be registered. So that is the first thing that we need to take care of. And upon payment of a registration fee, if you haven't paid a registration fee, Taifa Sacco will not register you. Okay, so the first thing that we're going to do is to take care of the registration first. So And how we can do that is just a simple if statement, but not the actual if that you would write in a C program. You'll see how I'll write mine, but it can be flexible as long as you say you express what you're trying to do. And this is question 3. Question 3. Taifa Sacco pseudocode. Pseudocode. And what are we told here is that we are told that a member registers upon payment. So it's only if and if you paid is when you'll be registered. So the first thing that we need to write our pseudocode is we have to start. So always know that in your pseudocode you have to start and stop. And now the second thing that we need now to do is to we need to now register our applicant. So I can have a comment, but let me just, and how can we register our applicant? So we can say if applicant has paid registration fee, then do what? If the applicant has paid the registration fee, then you can mark the applicant as a registered member. Then you can mark the applicant as a registered member. So here you can just output, or you can print something like registration successful. So you can see it's just basic English terminology that I'm using. So if the applicant has paid the registration fee, then mark the applicant as a registered member, and you can print registration successful. How about if they haven't paid the application registration fee? So you can say else. So else, this means that they have not paid the registration fee. This means they haven't paid the registration fee. And then else, you can just tell them, you can print you have to pay the registration fee to become a member. So you say you have to pay registration fee to become a member, and do that. So this is how you can do the registration. So if the applicant has paid the registration fee, then mark the applicant as a registered member, and you can tell them that the registration is successful. And then we go to the next statement, and it's saying that if where then a registered member may apply for a loan after making monthly contributions for at least 6 consecutive months. So a registered member, notice that it's only a registered member. So you first have to ensure that the member is actually registered. Okay, so here is to apply for a loan. So if the member, so we are dealing with now the members. So if the member is registered, then do what? If the member is registered, then you can test whether they have monthly contribution for at least 6 consecutive months. Then if the member is registered, so this is our first condition. Then if the same member, if the member, or you can just say the member, if the member has made 6 consecutive monthly contributions. So if the member has at least 6 monthly consecutive, and it has to be consecutive because that is what we've been told, 6 consecutive monthly has at least 6 monthly consecutive contributions, okay, then do what? If the member is registered, and if, okay, so you can actually say and if the member has, so you can say here and or then, and if the member has at least 6 consecutive monthly contributions, here is now where we are able to get the loan. So you can print like something like the loan application successful. So you can just print your own things to ascertain that the loan application has been successful. So because these will test out that they are a registered member and they have at least 6 monthly consecutive contributions. And to take care of this, if that is inside here, we say else. So else, it means that the member has not contributed at least 6 consecutive months. So else you can say print you have to have you need to so you need to have contributed at least 6 consecutive monthly contributions, something like that. You need to have contributed at least 6 consecutive monthly contributions. So that will take care of the if that is here. And then the other if, the one that we add here, if the member is registered, we can say that else. So this is taking care of the if the member is not registered. So this else here is taking care of the if the member is not registered. So else, what do? We print that you need to register as a new member first. Okay, so the first if ends here. Okay, please note this, the inner if, this if that is inside here that will test for your 6th monthly contribution, it ends here. So you can say and if it ends here, this one ends here. And the other one, now this other else is that if you are not registered as a member, so you print you need to register as a member first. And now that ends our end if. This now will end the first if that is here. So that is how you can actually do that. So to just give some indentation, I can do that. So this if that is inside here is used to test if the user has at least 6 monthly consecutive contributions. So you print out the loan is successful. So this is the pseudocode that you can write to do that, and then you stop. So we started and then we stop there. So you can see that if the applicant has paid the registration fee, then mark the applicant as a registered member. So you can print registration successful. Else, you have to pay registration, blah, 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 to become a member. And that marks our end of the if statement. So the first if ends here. So end if. It ends here for this first if statement, and then for this second one it ends here, and this inner one it ends there. So that will take care of our logic, and if you are to give this to someone, they can be able to implement the logic. And I hope we're still together. So can you guys see my screen? I hope you can still see my screen. Uh, so we'll look at the next question, and if you have a question on that, you can actually just shoot out if you have a question on that. So we'll look at the next question, which is write a C program that stores 5 elements in an array. The program initializes the value of each element to the product of its index and 5. The program then outputs the elements in reverse order of initialization. So in this case, we'll be dealing with an array. We'll be dealing with an array, and we looked at how arrays contain different indexes. Okay, our arrays will contain different indexes, and what we are told is for each index we multiply each index to 5. So the program initializes the value of each element to the product of its index and 5. The program then outputs the elements in reverse order of initialization. So let's see how we can do that. And this was the pseudocode for the Taifa Circle. And let's do the next one. And the next one is requiring us to do what? It's question 4. Question 4, and this is the array initialization and output. So we are told to stores 5 elements in an array. So we need our array, so we can say int array, and our array is normally represented like that, and it has 5 elements. And we say that there are multiple ways to initialize or declare our array. We say that if we wanted to give these array values, we could say something like array index 0 is equals to something like 45. If it was for max, then you say array index 1 is equals to 54. Then array index 2 is equals to something like again 54. Then array index 3 is equals to something like 65. Then array index 4 is equals to 99. This is one of the ways we can initialize our arrays. And we said another way, instead of doing this manually, you can use an array initializer, of which an array initializer normally looks something like this. You say something like that, and then you have your curly braces, and then you give values the way that they are lined up. So 45, 54, 54, then 65, then 99. This is how you can also initialize your array. So this one is given index 0, 1, 2, 3, 4. And we saw that to deal with arrays, we normally use loops to deal with our arrays. And to just do that in a very simple way, we can use a for loop to access each element of our array. And what the question is telling you, initializes the value of each element to the product of its index and 5. So to the product of its index. So what is this index? 0. So here it should be 0 times 5. Here it should be 1 times 5. Here it should be 2 times 5. 2 times 5. Here it should be 3 times 5, and then here it should be 4 times 5. So this was just a recap of how we said an array. So this is what we are required to do. This is what the question requires you to do. But we will be doing this automatically using a loop. And how can we do this automatically using a loop? We can just declare our array and then use the value of index I. Okay, so you can say int I or index. Then you say, you start with the for loop. So you say for I is equals to 0. So I is starting from 0. Then I is less than 5. And then I plus plus. And what do we need to do? We need to multiply the I and 5 for every index. So this will just say array, then index I is equals to I times 5. This is exactly what we just required to do. And if we were to do this, it would if we were now to print our array, so print our array. So we can use a for loop to print. So you say for I is equals to I is equals to what? I is equals to 0. Let's print it out from the start to the end in from 0, from the first one to the last one. But our question is asking, then output the elements in reverse order. So let's start from 0 to index 4. So I is less than 5, and then I plus plus. And then we can printf. We can printf percent what? Percent %d. And then we can go to the next line and say what you need to print is our array index I. And do that. So now this should print out our array, and it should be something like 0, 5, 10, 15. So you can see 0, 5, 10, 15, 20. But now what we are required to do is to print out in reverse order from the last one to the first one. So we need to print out from the last to the first. That is now the reverse order. And to do that, we just start with the last index, and the last index is 4, because we are going from 0 to 4. So that is what I recall telling you about. If we have 5, the last index is normally 4. If we have here something like 15, 25, the last index is normally 24. So the last index is 4, and then I should be greater than or equals to 0. So we are going from 4 to 0. And then we are not using I plus plus, we are using I minus minus, because we are now decreasing. Remember what we did in the while loop. If we wanted to decrease, we were using the number minus minus. It's the same case for this, I minus minus, and that should print out in the reverse order. And you can see it's printing out 20, 15, 10, 5, and 0. So print our array in reverse order from the last index. Declare our array, and then I variable to be used as index times 5, as index times 5. And that is what we are doing here, I times 5. So here we are multiply index, or multiply the index and 5. That is what we are doing here. So this is how we can answer that question. So array initialization and output, that is the code that was needed for that. Then we have the other one is question 5, I think. Question 5, and what does it say? Write a program to open a file called student file containing letters ABC. Read and display the content using the getC function. So I think we can do that as the last one, because we need to start creating a file and writing that. So let's do this one as because it's very simple and we did it last time. The grading system that can be used to grade a student using a switch structure. Last time we used an else if statement. Now we are asked to use a switch statement to actually do this grading system. And we actually also, I showed you, I think there was a question that was asked how we can use a switch statement, and I actually showed you how you could use a switch statement to do that, but we'll repeat it because I'm seeing that these marking scheme is grading system is different. So we can say question 6, grading system using switch statement, yeah, using a switch statement. So what you need to do is can be used to grade a student using a switch structure. I think for your case you can just write the switch statement, but in this case I can tell the user to input a mark and then determine from that. So printf and then say please input your marks, and then we can go to the next line and do that. And to declare our marks we say int marks, and then we scan our marks and then say scanf %d and marks. So that will scan our marks. So here is where now we use a switch statement to determine the grade of the mark that has been input. So we'll say switch, and then what do we want to switch? Our marks, the mark that has been input. And then how a switch case work? It works with different cases. So you say case, the first one is below 50. So it's something like 0 to 50. So you can say case 0 to 50. So to represent a range in a switch statement, use the 3 dots, 0 to 50. And then you write the full colon, and then you say break. So this will take care of the case from 0 to 50. But in this case, you can see it's saying below 50. So 50 is actually not included. So below 50, it means it's 49 and below. So here we need to have it as 49. Because 50, 49 not 69, because 50 is actually a D. 50 is in the other marking scheme. So here 0 to 49 we can printf grade is, and then what is the grade? We can say it's an E. So grade is E, and always go to the next line. And then we can do the same thing for the other cases. So case 50 to 59, and then you say break, and then you printf and say grade is D. Grade is D. Printf. I didn't write printf, and I can go to the next line and do that. And then the other case is 60. You can see that there's no 60, so we'll do as we just told, 70 to 79. So case 70, 1 2 3 to 79, and notice that they have to be 3 dots, not 2 or not 1. And then you can say printf grade is C, then go to the next line, then do that. And then the next case is case, I think it's 80, 1 2 3 to 89, and then you say break, and you can printf, then say grade is B, then grade is B, then go to the next line. And the last case is 90 to 100. So case 90, 1 2 3 to 100, and then say break. And after that you printf grade is A, and go to the next line and have our semicolon. So that is basically it for our grading system. The thing that you need to know is to represent a range in the switch case statement is you use the 3 dots, and then you write the first number and the last number between that range, and they are inclusive. So if I was to run my program, it will tell me to enter the marks, and then it will give me the grade. So if I input 43, that is an E. You can see that it's saying that the grade is an E. If I input something like 70 to 79. Let's see, 70. 70. That should be a C. So you can see that the grade is a C. But since we don't have any range between 60 to 60 what, if I input a mark like 64, 64, you can see that it won't do anything. It will just exit because we haven't catered for the 60 to 69 range of our marks. So that is how you can do. In if you were to get an A, it's something like 97. That is an, you can see that the grade is an A. And that is how we could have answered that question. And that is for the switch case. So grading system using switch case statement. So that is it. So that is what you could do. And now for the last question is write a program to open a file called student file blah blah blah. And so what you need to do here is to now create that file. So I can create my file in this directory. So I can right click and say new file. And what type of a file is it? I can say it's a it's a text file. So how do we call it? How is the text file called? Student file .txt. And I will have it in the same folder, and in this file I will write ABC. I think it's written containing letters ABC. Read and display the contents using the getC function. So this is trying to show us how we can use the file library in C. So remember that we have included the stdio. We have majorly been using stdio for just printf and scanf, but the standard input and output library can do quite a lot. It's not just the scanf and the printf. You can also read from files using some functions in the input from here, such as reading from files, reading from other different input streams. So to read from our files, what we need to do is to create our file variable. You create a file variable, and to do that you say file, and then it's a pointer, and then say file. You can name it as file, and then whatever you will be reading in a file, it's stored in a character. So we can store it because it will read character by character. So you can store a character, you can name it character ch. And this file is what we will have here. And when we go to open the file, you'll see how we can open the file. So first thing that we do, we can open the file in read mode. So we are not writing. There are so many ways to open a file, such as read mode, read and write, read binary. So there are so many different ways to open a file. So you can also write and also write binary, write plus. But what you really need to know, there's also append. What you really need to know is if you want to open a file in read mode, you say R. And where do we use this? We use these now here where we want to open a file, and then say file is equals to fopen. Okay, so this is now our function to open our file. Here we are doing opening the file using the fopen function. So fopen, and what you normally give the fopen function is the name of the file or the location of the file. So in this case, my file is named as studentfile.txt. That is how I named it. And then you give it the opening mode. Okay, whether you are reading it, whether you are writing it, whether you are reading binary, whether you are writing binary, whether you are appending. So for appending, is if you are writing to a file and you do not want the contents of the file to be deleted. So it will write at the end of the file. That is what you mean by appending a file. And if you were to write, it would actually replace the file with the new things that you have written. So in this case, we want to open the file in read mode. So we say R. And then since here we are trying to open a file, we need to test that the operation has been opened successfully. So you say if file is equals to null. This means that the file has not been opened successfully. So this means that that the file hasn't opened. Yeah, we can say opened successfully. If the file is equals to null, what can you do? You can say printf error opening. You can say opening file. So you can say that there was an error opening file, and then you can return 1. So here is actually where you can see another return type. So you can see at the end we are returning 0, but here I told you when you return any other number, it's associated with when your program encounters an error. And you can see here we are returning error 1, error code 1. So maybe for your team or your program, it will know that every time I experience an error 1, it's attributed to a file not opening. Okay, you can also return anything you want. You can return 134, but we can just return 1, okay, to attribute. So when the program reaches to return 1 here, it will stop at that. It won't continue. That is why we are testing if the file is null, so that we do not, our program does not crash when it tries to read from a file that has not been opened successfully. And then now after doing that, here is where we now read and display the contents of the file. So here is where we read and display the contents of the file. Now here is where using the getC function. This is the function that can now be used to read the contents of the file, and in our case it's just ABC. So we can have something like contents of our file. So you can say printf contents of our file, and then you do like that. So it should say the contents of the file and then do the contents that it has read. And how do we read from our file? We need to have a loop that will read from our file. And how can we read? So you can say our character. Remember that single character to be read from the file every time in the loop. So a character, this is now the character that will be read from the file, because it will read character by character. So we say the character is equals to now getC, and then getC from where? Where do we get our, where are we reading from? Our file. And here we have to say is not equals to EOF. And what does EOF means? EOF means the end of the file. So we are reading as long as we are not at the end of the file. So it's reading everything as long as we don't get to the end of the file. So when we get to the end of the file, our loop will stop. And how can we now display what we have read? So you say put C and then the character that we have read. Just that. So how we can read is we're using the getC function, and how we can output is using the getC. The the put char method, okay? Get C, and then to read from the file, and then the put character, put C or put character, the character that we have read over here. And now when I run this program, it should now read from this file and give us ABC. So let's see whether it will work. But it can refuse to work because here you're supposed to provide the full path, okay? You're supposed to provide the full path to where this file is located. But in your case, since you're not using a computer, let's say it's an exam, you're supposed to just write the file name as it is. But in this case, you'll see that it might experience an error in opening my file. So let's see. So let us see whether exactly. So you can see error opening file, and the program ended with exit code 1. So you can see here it's saying ended with exit code 1 because I am returning 1 because I experienced an error. So it's not even printing out these contents of our file. So anywhere the computer meets with return, it normally stops execution of whatever is below that. Okay, so whatever is below here, it won't be executed. And if I wanted my program to work, now here is where I need to provide the full path. So I say show in Finder and then provide the full path to this. So I can say get info and then copy this path. So this path is like this, and then copy it and then paste it in my code, paste it right over here. So you see, users, so this is the entire path that is needed. Users, Eric, desktop, C programming, cat2 revision, blah, 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 student file.txt. And now if I now read from that file, let's see whether it will give me the contents. And you can see it's saying the contents of our file is ABC. So it has read from our file. And if I was to add a different content, so I can say 1, 2, 3, something like that, it should read all this content. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. If I was to give it that, it should read all these files. Okay, it should read all these files and execute that in our display. And as you can see, contents of our file, it's starting with ABC, whatever I've written, and ABCD blah 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 up to Z. So that is how you can deal with files. So the most important part is now how you can use this fopen function. So let me just have it remain like that. And yeah, and while you're reading, you use a while loop that reads every character using the getC function from the file, as long as we are not at the end of the file. And then to display, you say you can put character with the character that we have read. So it will output every character every single time, and then it will display your file and what was contained in your file. So that is it for that. So I can copy this code and have it here, the answers. So I can copy, and where is our question 5? It's right over here. Yeah, so that was it for our card. Okay, that was it. So I think we have answered everything as to how we were required to do, and I'll be sharing this with you. And that was it. That was it for the session, and I think the recording will be shared too. Yeah, the recording will also be shared. So that is it for the session today.